Good day, everyone. Today, I'm going to present a novel approach of ranking of alternatives through functional mapping of criterion subintervals into a single intervals, or RAFSI method under a Fermatian environment. Okay. This is the introduction. Multi-criteria decision-making is a prominent methodology in the domain of soft and applied sciences. It is generally utilized to select the most optimal decision among multiple attributes or criteria, given that there is no dominating attribute or criterion. There are several applications of multi-criteria decision-making. For example, like material selection, sustainable engineering, preventive maintenance planning, financial management, energy policy management, supplier evaluation and selection, business process information management. The novel of MCDM, there are some, for example, like a combined comparison solutions method, evaluation-based distance from average solution, full consistency method, measurement of alternative and ranking to compromise solution method, simultaneous evaluation of criteria and alternatives method, ranking of alternatives through functional mapping of criterion subintervals into a single interval method. So, ranking reversal problem, the preliminaries. For example, this one, this is actually the Fermatian fuzzy sets. So this is the definition, and this is actually the Fermatian fuzzy set T. Okay, so this is actually the function, and this is actually like the explanation of it. And then this is actually the definition too for the Fermatian fuzzy sets. As you can see, this is actually also the equation. And then let's go to the third one. This is the third definition, okay, of the Fermatian fuzzy sets. And then let's go to the next one. This is the next definition. Okay. And then let's talk about the steps of the RAFSI method. So step one, determine the alternatives and the criteria to construct the initial decision-making matrix. The step two, define ideal and anti-ideal values. Step three, construct the standardized decision matrix. Step four, calculate arithmetic and harmonic means. And step five, form normalized decision matrix. And the last one, calculate criteria functions of the alternatives. Then let's see the proposed method of the study. Okay. So the step that what we would like to propose is actually the step 7 and step 8 in here, because like step 1 to 6 is actually the same with the previous one. So let me go back again. Okay, what are those steps? Okay, the first, determine the alternatives and the criteria to construct the initial direct relation matrices. Transform the initial direct relation matrices into equivalent FFS and aggregate. Attain the corresponding Cripps values of the aggregate FF direct relation matrix, define ideal and anti-ideal values, construct the standardized decision matrix, calculate arithmetic and harmonic means, and these are the seventh and the eighth steps. The step is form normalized decision matrix, and last one, calculate criteria functions of the alternatives. So let's see the illustrative example. Okay, using like one data. So it's going to be like this one. Everyone, expert 1, expert 2, expert T from this study. So these are actually the C1, C2, C3, C4, C5, and this is actually B1 until B17. Okay, so this is actually like the data set. And then this is actually like the ranking, and this actually like the factors. For instance, like visibility, risk, reliability, duration of preparation phase, duration of implementation phase, and so on and so forth until the economic value. So let's see the model validation. Okay, so this is actually like B1 until B17, okay, just like from the previous illustration, okay, everyone. And then this is actually the blue one is actually the Cripps, the green one TIFN, and this is actually the red one FFS. Okay, and then the next one, this is actually like you can see for the Cripps B9 and B15, TIFN B5, B8, and FFS B5 and B8. So let's see the conclusion of this study. So multi-criteria decision-making is a prominent method in identifying strategies to various decision-making problems. However, a rank reversal problem is present in most models. A novel approach to integrate Fermentian fuzzy set in RAFSI is proposed in this study. Among the limitations of this study is the limited fuzzy sets utilized to compare the results. And last, as a future research agenda, the application of the novel approach to real-life scenario must be executed. That's all the presentation. Thank you, everyone.